Hi, welcome to Lesson 7 of Arcs, Sectors and Angles and Circles. Today we're going to move on to angles formed in circles. Before we have our lesson, let's have a starter. Okay, so today's starter is just a little bit of revision on angles and triangles. Remember where you see the paper and pencil icon to complete the notes and examples into your notes jotter or any work into your class jotter. Right, let's pause the video and have a go at question 1 and 2. Okay, let's have a look at the answers. Question 1A. The three angles in any triangle add up to 180 degrees. 1B. The triangle with three equal sides is called an equilateral triangle. 1C. The triangle with two equal sides is called an isosceles triangle. Question 2. Calculate the size of angles X, Y and Z. So in 2A, we have a straight angle, and this has been divided into two parts with 65 degrees on the right-hand side and X on the left-hand side. To calculate angle X, we need to remember that a straight angle is 180 degrees. So we do 180, take away 65, and that leaves us with 115 degrees. In 2B, we have a triangle. The lines with through the sides indicate equal sides, so we have two equal sides, so we have an isosceles triangle. So therefore, we have two equal angles, and in this case, the other 39 degrees is at the other elbow, if you like, of the isosceles triangle. To get angle Y, we need to add these two angles together and then take the answer away from 180 degrees because we know the three angles in any triangle add up to 180 degrees. And this will give us an answer of 102 degrees for angle Y. In question 2C, we also have an isosceles triangle, but this time we have been given the angle at the vertex between the two equal sides. So our method is slightly different. This time, our two equal angles, again, are at the elbows of the triangle. So we have two angles Z. We have to take 84 degrees away from 180 degrees to see what is left to share equally between the two angles at the elbows. So this time we do 96 degrees divided by 2 and we get Z equal to 48 degrees. Okay, so let's look at today's lesson then. So today we are going to look at finding missing angles formed in circles. By the end of the lesson, we should be able to identify an isosceles triangle within a circle and use the properties of angles and triangles to find missing angles within a circle. Okay, so here's example 1. Remember to copy this into your notes. So, a chord is a line joining 2 points on the circumference. We can see in the diagram we have point A and point B, and this has been joined by a blue line. So this blue line is a chord. We call this chord AB. Point of information is the diameter is a special type of chord, and that's because it passes through the centre of the circle. Now, if we draw a radius from point A and point B to the centre, we can see that an isosceles triangle is formed. So let's remind ourselves about the special properties of an isosceles triangle. So an isosceles triangle has two equal lengths, so two equal sides, and also two equal angles. Those angles will be at the end of the equal sides. So as I described earlier, the elbows, if you like, of the isosceles triangle. Now, if we split an isosceles triangle right down the middle, we get two identical right-angled triangles. We will use that fact in tomorrow's lesson. Lastly, this applies to all triangles. The three angles in any triangle add up to 180 degrees. We will use these facts in today's lesson. Okay, let's look at example 1. Again, remember where you see the pencil and paper icon, copy these into your notes jotter. So in example 1, we have been asked to calculate the size of angle ABO and angle AOB. Remember, we name an angle with 3 letters, and the middle letter is the vertex of the angle, so that's the corner or point of the angle. So in this case, angle ABO is the angle at vertex B, and angle AOB is the angle at vertex O. Let's take the triangle itself. So OA and OB are radii, so therefore we have 2 equal sides. If we have 2 equal sides, then we have 2 equal angles, so those equal angles are at the end of those equal sides, so at the elbows of the triangle. So we know that 3 angles in a triangle equal 180 degrees, so to get the last angle in the triangle, we add these 2 angles together and take the answer away from 180 degrees, and that gives us 108 degrees. So from the diagram, angle ABO is 36 degrees and angle AOB is 108 degrees. Let's look at a second example. So this time we're asked to calculate the size of angle X. In order to do that, we need to remember that 2 radii in a chord equal an isosceles triangle. So let's take the triangle out and label it. We can see from our original diagram that CA and CB are the radii, so these are the equal sides. X is at vertex A. But in order to work out the size of X, we need to get the angle at vertex C first. Now remember, there are 360 degrees in a circle, so we would do 360, take away 280 degrees, which will give us 80 degrees at vertex C. So now we know the angle between the 2 equal sides in the isosceles triangle. So remembering that 3 angles in a triangle add up to 180 degrees, if we take 80 away from 180, that leaves us with 100 degrees to share equally between vertex B and vertex A. So we divide 100 by 2, and that gives us 50 degrees at vertex A and vertex B. So angle X is equal to 50 degrees. Right, now it's your turn. So complete the following questions into your class jotter. For each question, sketch the triangle and fill in the angles. This will help you. Check and correct your work at the end. So here goes.